Let's talk about the preparation of haloarenes. Haloarene simply means that we have a halogen directly attached to an aromatic group. In this case, that's going to be the benzene ring. So let's talk about the preparation of haloarenes, that is halobenzenes from the very first thing, benzene. Now, benzene can be converted into the haloarenes by simply reacting with the halogen in presence of a Lewis acid. The Lewis acid is going to react with the halogen and convert it into a electrophile. It's going to convert it into electrophile. It's going to pull away the electron cloud from halogen, getting converted into X plus, that is a halonium ion, along with the XLA minus. Now, this happens to be the electrophile. We already know the reaction of benzene ring with the electrophile. It is going to attack on the benzene ring, create the cation, and then the new electrophilic substitution reaction would take place. Here we generally talk about that the halogen is going to attach to the benzene ring along with formation of HX. HX actually is never formed because a Lewis acid is going to consume this particular HX, and we have HLAX that's going to be formed. But fine enough, this is way to write it. So here we get haloarenes. Here the X2 can be Cl2, it could be Br2. If we are going to use I2, that is, we react the benzene ring with iodine, then in that case, the Hi, which is formed in this reaction, is actually a reducing agent. So, to make the reaction move in the forward direction, we have to consume the Hi which is being formed in the reaction. This Hi can be consumed by treating with HNO3 or HiO3. These two being oxidizing agent are able to consume the Hi, and so the reaction keeps on moving in the forward direction. So here we are going to get iodobenzene along with Hi. So that could be the method of preparation of haloarenes directly from benzene. The haloarenes are not prepared from phenol. In the case of phenol, the oxygen benzene bond is much stronger and it's not easily consumed. The bond is not easily consumed. It is not possible to create the haloarenes from phenol. Now, to talk about further, if we have the preparation of haloarenes, this haloarene can actually be prepared from aniline. We have aniline and we react aniline with HNO2. This is what we call as nitrous acid. The nitrous acid is not a stable acid, so it is not being used directly. In fact, nitrous acid is being prepared right in the reaction mixture by reaction of NaNO2 with any strong mineral acid. Mostly that strong mineral acid is HCl. We can use H2SO4 also here in this reaction. We can even use HNO3, but the most often the acid which is used is HCl. It's a strong acid and it's also not an oxidizing or a reducing agent in any case. So here we have NaNO2 and HCl. This NaNO2, when reacted with HCl, it is going to convert aniline or NH2 into a diazonium ion, N2 plus Cl minus. This particular compound is benzene diazonium chloride. Now, this reaction generally takes place between a temperature of 0 to 5 degrees Celsius, that is, it takes place in an ice bath. Otherwise, this particular diazonium ion which is being formed is highly unstable and is able to decompose to give the carbocation, and the reaction is completed. So we have to keep the temperature at 0 to 5 degrees Celsius. So this particular diazonium salt remains stable for a certain duration of time. Now, this particular diazonium salt can further react in many ways to give the aryl halides. We have N2 plus, Cl minus. If this N2 plus Cl minus is reacted with CuCN in plus of presence of KCN, we get benzonitrile. Now you might be surprised that when I'm talking about haloarenes preparation, why I'm talking about the benzonitrile preparation or cyanobenzene preparation. The answer to that is that cyanide is considered a pseudohalide. So many places the cyanide is able to react and behave as halogen or halide ion. So here we have it. Now if we react it with CuCl in presence of HCl. Now it could be something like some books may refer to as Cu2Cl2. That's the same thing. Then we get the chlorobenzene. If we have the CuBr along with HBr, we get bromobenzene. Now these three reactions are termed as Sandmeyer's reactions. The same reaction could take place if we directly use copper along with the halogen acids, like we have N2Cl minus N2 plus, and here we react it with Cu in presence of HCl. Then the reaction says that some amount of CuCl will be formed right in the reaction mixture, and that CuCl would act as the catalyst. We could have Cu along with HBr. That also is going to give us bromobenzene. Now, these two reactions are termed as Gattermann's reaction. The Gattermann's reaction give a poor yield as compared to the Sandmeyer's reaction. If we are supposed to get it converted to iodobenzene, there we do not need any copper compound for a catalyst. What we can simply do it is we can simply get it along with Ki and convert it into iodobenzene. To convert it into fluorobenzene, we have only one particular reaction. That is, we have this benzene diazonium chloride and we treat it with HbF4, fluoroboric acid or tetrafluoroboric acid. If we treat it with HbF4, then in that case, this gets converted into N2 plus BF4 minus, benzene diazonium tetrafluoroborate or benzene diazonium fluoroborate. Now, when we talk about this particular compound, this again is a diazonium salt, but it is a stable diazonium salt. It can actually be prepared and stored under refrigeration. Of course, it's not that stable that we can put it anywhere, but it does. It happens to be having a certain stability. This benzene diazonium salt, this particular diazonium salt, can be used to prepare many other compounds. But in this case, we are using it to convert to fluorobenzene. Simply heat it, and here it gets converted into fluorobenzene. Now, this particular reaction is termed as Ball's Schiemann reaction, and this is the only practical method of preparation of fluorobenzenes in any case. This is the most important and the only method of preparation of fluorobenzene.